I'm going to go over lift. Basically, lift cannot fully be explained. However, the best explanation that we can get is the conservation of mass and the formulas of two other men. First of all, the conservation of mass. This is the formula of conservation of mass. Basically, what the formula is telling us is whatever goes in must come out. Now here's a pipe. If you were to push air through this pipe, the rate the air would be pushed in would be exactly the same if it came out. However, if the middle of the pipe was slightly thinner than the rest of the pipe, it would speed up. But the air at the end would come out exactly the same. Now you see streamlines running through the tube. The streamlines are very similar to the streamline you see here. Now the streamlines in lift have stream tubes, which can be seen as wind tunnels. Now air cannot cross between each other. But as you can see here, the pressure is lower at the top and the pressure is higher at the top, which means if the pressure is higher, the airflow is faster. As you see here, the lower pressure is at the top, so the air is flowing faster at the top. So the top speed flows faster than the lower speed. Now next we move on to Bernoulli's. Now Bernoulli's equation is that, which is basically saying when a fluid is sped up, the static pressure is lower, whereas slow moving fluid would have higher static pressure, as you can see here. Now here we see the lower pressure at the top. And since air always wants to move more into the lower pressure zone, and considering the lower pressure at the top, this causes the wing to be sucked up, and we get lift. So now we move on to Newton's contribution. His third law clearly states, with every action there is an equal and opposite reaction. When there is no movement of the wing, there is not much reaction we get, as you see here. If, however, there is some movement, the air tends to travel around the wing and gives us an upward shear and a downward shear. It also creates whirlwinds on the back. This upwash gives us, it cancels out the downwash, which gives us a downward deflection of air. Again, with every action there's an equal and opposite reaction. Now we move on to Newton's law. Newton's third law states, with every action there's an equal and opposite reaction. Here you see a ring, there's no reaction, because it's stable, it's not moving. Now if this made a movement, we'd get this sort of reaction. You see the air flowing around the wing, which gives us an up, and air is deflected downwards. At the downward area, this downwash involves whirlwinds around the wing. The upwash cancels out the downwash, which gives us a downward deflection of air. Again, with every action there's an equal and opposite reaction. The air forced downwards by the wing will now force the wing upwards and add to the lift. Finally, this brings us on to the lift formula. This is the lift formula. Now I'm going to show you a short clip about lift formula and how deep it is.
This, L, stands for lift. It is what we are trying to find out. This, D, stands for the density of the air. Here is a picture of high density air, and here is lower density air around an airfoil. As a wing passes through high density air, more air particles will pass over it. If there is more air passing over the wing, then more lift will be created. Wings passing through lower density air will have less air particles passing over them, so there will be less lift created. We are still traveling at the same speed, but because there are less air particles around the wing, they pass over the airfoil less frequently. This, V, stands for the velocity of the aircraft. Here, you can see we are traveling quickly, and lots of air particles are traveling over the wing in 1 second. Just as before, more air particles passing over a wing means more lift is created. When we go slower, as we are here, less particles are traveling over the wing, meaning less lift is generated. This is why aircraft have to run down the runway quickly to get lift, and can't take off while the passengers are still boarding. This S stands for the area of the wing. Here is a small wing, and some blue circles to represent air particles again. As you can see, it cannot hold as many air particles as this large wing. The larger the wing, the more lift it will produce. Yet again, more air particles passing over the wing means more lift. This CL stands for coefficient of lift, which varies depending on what shape the wing is, and also the angle of attack. The easiest way to control an aircraft is by altering the angle of attack at the various primary control surfaces.
And now you know exactly what the lift formula means, which wasn't as difficult as you thought. Basically, the higher the density air gives us, the more air particles, which means more particles passing over the wing and gives us much more lift. I hope you have a better understanding of lift. Thank you.